So let's talk about the behavior of graphs of rational functions near their vertical asymptotes. So if n is even, then and is a factor of f of x, then the graph will behave in the manner given. So if n is even, they both approach the asymptotes together, whereas if n is odd, it is going to have one above and one below the denominator. So why don't we go ahead and practice graphing some of these. So if I have f of x equals 2 over 3x plus 1, we found its asymptotes earlier, right? So its vertical asymptote is going to be my denominator set equal to 0. I subtract 1 from both sides. I get 3x equals negative 1. I divide both sides by 3, so I get x equals negative 1/3. I then see for my horizontal asymptote that my numerator is of lesser degree than my denominator, which means I'll have a horizontal asymptote at y equals 0. So I like to go ahead and graph my asymptotes. We'll do that in blue. This is just the lines that my graph will not cross. So here's x equals negative 1/3. Nope, that's positive 1/3. Let's try again, Ms. Miller. Negative 1/3. And this is y equals 0. So I want to find 3 points on each side of the vertical asymptote, just so I can kind of see what my graph is doing. So on the left-hand side, I'm going to pick negative 3, negative 2, and negative 1. And on the right side, I'm going to pick 0, 1, and 2. So if I have 2 over 3 times negative 3 plus 1, that becomes 2 over negative 9 plus 1, which is 2 over negative 8, which is negative 1/4. So when x is negative 3, y is negative 1/4. So we're below the x-axis. So when x is negative 3, y is negative 1/4. I'm going to plot that in green. It's right about there. Let's plug in 2. I have 2 over 3 times negative 2 plus 1. 3 times negative 2 is going to be 6. Negative 6 plus 1 is negative 5. So I have negative 2/5, which is a little more than 1/4. So we're going a little lower. When I plug in 1, I have 2 over negative 3 plus 1, because negative 1 times 3 is negative 3. So I have 2 over negative 2, which is negative 1. All right, so my graph is looking like this, right? It gets really, really close to the asymptotes, but it never quite touches them. Okay, let's plug in when x is 0. When x is 0, I have 2 over 3 times 0 plus 1. Well, that's just going to give me 2. When x is 1, I have 2 over 4, which is 1/2. And when x is 2, I have 2 over 3 times 2 plus 1, which is 2/7, which is smaller than 1/2. So when x is 0, y is 2. When x is 1, y is 1/2. And when x is 2, it's getting closer and closer to this asymptote. So again, here's what my graph would look like. Just like a parabola where you have to find 3 points. When you're graphing a rational function manually, I would want to find 3 points on either side of the vertical asymptotes. And if you have 2 vertical asymptotes, you got to find 9 points. So let's graph another example. I have 2x over 4x minus 6. So in order to find my vertical asymptote, I set my denominator equal to 0. So I've got 4x minus 6 equals 0. So 4x equals 6. So x equals 6 divided by 4, which is 3/2. We've found these before. My degree of my numerator is the same as the degree of my denominator. So I'm going to have a vertical asymptote, a horizontal asymptote at y equals 2/4, which is a half, right? So let's go ahead and sketch our asymptotes. I've got a horizontal asymptote at y equals positive 1/2. And I'm trying my best to make these look like little dotted lines so we know they're lines we can't cross. And I've got a vertical asymptote. I was about to say license. Vertical asymptote at 3/2. That's 1.5. That's right here. Beautiful. Okay, I'm going to go ahead and I'm going to pick 3 points on either side of my vertical asymptote because that's what I said to do. For my left-hand side, I'm going to pick when x is 1, 0, and -1 because those are easy numbers to work with. On the right, I'm going to pick 2, 3, and 4. So 2 times -1, I'm plugging it into my function. 2 times -1 over 4 times -1 minus 6. That gives me -2 over -4 minus 6, -10. So I get a positive 1/5. Cool. So when x is -1, y is positive 1/5, which is still below, my line right here, positive 1/5 is less than a half. When x is 0, I've got 0 over -6, so that's just 0. And when x is 1, I've got 2 over 4 minus 6, which is 2 over -2, which is a -1. So here is my graph. It looks very similar to the one we drawn before. All right, let's check on the other side of our asymptote. So when x is 2, I've got 2 times 2 over 4 times 2 minus 6. Well, that's 4 over 8 minus 6, which is 2, so I get 2. So when x is 2, y is 2. There's our point right there. We'll plug in 3. That gives me 6 over 12 minus 6, which is 6 over 6, which is 1. So when x is 3, y is 1. And then when x is 4, I get 8 over 16 minus 6, which is 8 over 10, which is 4/5, which is above a half, but it's really, really close. So my graph is going to look like this. Beautiful. I think this is the last one we're graphing. So if I have, first to find my horizontal asymptote, I set my vertical asymptote. Let me drink some more coffee. I set my denominator equal to 0, so I get x equals 3. So my vertical asymptote is at x equals a positive 3. So right here. My horizontal asymptote is, well, my degree is not of my numerator isn't less than my denominator. So I know I don't have a horizontal asymptote at y equals 0. And the degree of my numerator and denominator isn't equal, so I don't take the ratio of their leading coefficients. What it is the degree of my numerator is exactly 1 more than the degree of my denominator. So I have an oblique asymptote. And I find that by taking my numerator divided by my denominator. And we did this, I think in the previous video, but I'll do it again. So what do I multiply x by to make it look like x squared? That's going to be x. X times x is x squared. Negative 3x times x is negative 3x. I subtract this to get a positive 3x, and I pull down my next term. What do I multiply x by to make it look like 3x? The answer is 3. 3 times x is 3x. 3 times negative 3 is negative 9. I subtract this and get a remainder of a positive 10. We ignore the remainder and just focus on the quotient that's left. So my oblique asymptote is y equals x plus 3, which is a horizontal line, which is a linear equation, right, with slope of 1 and y-intercept of 3. So we can go ahead and graph this asymptote. I'm just plotting all the points on this line. It kind of looks like a dotted line. Okay, so there's our oblique asymptote at y equals x plus 3. Now I need to find some points. I need to find some points on this line. So I'm going to go ahead and pick some on the left of my vertical asymptote and some on the right of my vertical asymptote. And this might get messy. Okay, so if I have x over y, on the left of my vertical asymptote, I'm going to plot 1, 0, and -1. So I have -1 squared plus 1, that's 2. Over -1 minus 3, that's -4, so I have -1/2. So when x is -1, y is -1/2. So we're down here. Next, I'm going to plug in 0. That's going to give me 1 over -3, so I have -1/3, which is closer to 0 than -1/2. When I plug in 1, I get 2 over -2, which is -1. So when x is 1, y is -1. So it's kind of going to take this shape, right? It approaches our asymptotes but never crosses them. All right, let's take a look at when x is, 4, 5, and 6. When x is 4, I've got 4 squared plus 1, which is 17, over 4 minus 3, which is just 1. So when x is 4, y is 17. Okay, it's like way up here. When x is 5, I've got 25 plus 1 divided by 2, which is going to be 26 divided by 2, so 13. So when x is 5, y is 13, just like up here. When x is 6, I've got 36 plus 1, which is 37, over 3, which is 12 and 1/3, so it gets a little bit closer. So I've got kind of this going on. You can see my graphs always approach my asymptotes, but they never cross them.